Okay, in this question, we're looking at the specific heat capacity required practical. So we've got to measure the specific heat capacity of an unknown metal. So the question reads, a student made measurements to determine the specific heat capacity of vegetable oil. Figure 1 shows the equipment used. So we've got a joule meter, an electric heater, a beaker, a top pan balance, and a thermometer. And part A is a 6-mark question. Describe how the student could use the equipment shown in figure 1 to determine the specific heat capacity of vegetable oil. Okay, so to understand specific heat capacity, we need to understand how we calculate it. And the way we calculate it is using this equation, that is energy equals mass times specific heat capacity times by the change in temperature. So C is the specific heat capacity. So we can see we need 3 numbers. We need to know the energy we put in, we need to know the mass of the object, and we need to know the change in temperature. Okay, so let's start with how we're going to measure each of those quantities and then discuss how we're going to use them. So the first thing we can do is the easiest. We can say use the top pan balance to measure the mass of vegetable oil. So we're being specific about saying what piece of equipment we're going to use, and we're going to say what we're measuring the mass of. We're not just saying measure the mass, that would be too vague. So measure the mass of vegetable oil. Okay, now we also need to know the change in temperature. Okay, if we're going to get a change in temperature, we need to heat it up. So we can then say heat up the oil in the beaker using the heater. Okay, so we said what we need to measure first, and we need to set what we're then going to change. Okay, next we can say measure the change in temperature using the thermometer. Now, there are several variations of this experiment where you can measure the energy in lots of different ways, such as you could measure the power output of the heater and measure the time to get the energy that way. You could also measure the voltage going through your heater and also the current and work out power that way. In this version, they've made it very easy and they've given us a joule meter. A joule meter is what it sounds like, and it measures the joules, the energy. Okay, so we can now say measure the change in energy using the joule meter. Okay, so what have we got so far? We've said we're going to measure the mass. Okay, so we've got this number. We've said how we're going to heat up the oil and what we're going to use to heat up the oil. We're going to say how we're going to measure the change in temperature. We said how we're going to measure the change in energy. Okay, so now we need to say how we're going to calculate the specific heat capacity. So what we're going to do is say calculate specific heat capacity by rearranging, because if you notice this is to calculate energy, not specific heat capacity, by rearranging the equation, can't write, E equals MC triangle T. Remember, the triangle means changing, so whenever we see this triangle, it means changing something, to C equals energy divided by mass times by change in temperature. Okay, you should be able to rearrange that yourself. That is maths that you've been able to do for quite a long time now. Okay, so that is how we're going to approach this question. Now remember, for a 6-mark question, especially one there's a practical, there's 3 levels to it. Okay, so if we look at a mark scheme, it says level 1 is going to lead to a valid would not lead to a valid outcome. Okay, there are some steps, but links are not made clear, so I get you 1 or 2 marks. A level 2 answer might not lead to a valid outcome, so you've identified most of the steps, but it's not a logical plan. But for full marks, you need to say it's going to produce a valid outcome. This is going to produce a valid outcome because we have identified all the steps that we need to calculate the specific heat capacity. Okay, so moving on to the rest of the question. Give one risk when using the equipment in figure 1. This is something measuring specific heat capacity or heating something up, so the obvious risk is burns. Okay, that's all you need to write. Okay, you could say scalds, okay, because it's an oil, okay, so a burn from a liquid is known as a scald. You could also talk about breaking the glass. If you just said the oil is hot, that would not give you a mark because that's insufficient information, okay? The next part, a different student did not have a joule meter and calculated the energy used in the electric heater. Use the physics equation sheet to answer parts C and D, okay? So, firstly, there is a big hint here. You need to use the equation sheet. You will be given the equation sheet in the exam and it will tell you all the equations you need to know. Write down the equation linking energy transferred, power and time. So what you need to do, you need to look on that equation sheet and find an equation that has energy, power and time. And that is going to look like this. Power, it might be rearranged slightly differently, equals energy transferred divided by time. Okay. For our next part, the electric heater had a power output of 50 watts. Calculate the time taken for the electric element, or the heater, to transfer 4,750 joules of energy to the vegetable oil. So, let's start off with this equation that we've just written down. Okay, it does tell you we can use the equation sheet for parts C and D, so we're definitely going to be using this one. What have we been given? We've been told the power, we've been told the energy, and we want to work out the time. So, power equals 50 watts. Energy equals 4,750 joules. Time, don't know. So, what equation has power, energy, and time? Well, we've just found that out. It's power equals energy divided by time. So all I'm going to do is I'm going to substitute the numbers I already know into my equation. So I'm going to say 50 is equal to 4,750 divided by T. Okay, that was going to get you 1 mark. Your second mark is going to be for rearranging this to get T on its own. This is something you should all be able to do. This is basic maths. So we're going to do 4,750 divided by 50, and that is going to give us T. Okay, now all we need to do is put this into our calculator and we will get, what will we get? We are going to get 95 seconds equals T. Just pop that into my answer space, and conveniently the units have been given for you. So 1 mark for substituting your numbers into the equation, 1 mark for rearranging the equation, and your final mark for the answer. For our next part, we've got a graph. In a deep fryer, vegetable oil is heated by an electric heating element. Food is then cooked in the hot vegetable oil. The deep fryer contains an electrical component to monitor the temperature of the vegetable oil. Figure 2 shows how the resistance of this electrical component changes with temperature. And here we've got a graph of resistance against temperature. Part E. What electrical component is used to monitor the temperature of the vegetable oil? So this is crossing over into the electricity topic. You do have a list of electrical components you do need to know the symbols of and you need to know the function of, and the one that is going to change with temperature is known as a thermistor. Okay, so it's in the name. It's kind of like a cross between thermal, i.e. to do with heat, and resistor, which resists. Flipping over. For F. The electric heating element in the deep fryer automatically switches off when the vegetable oil reaches a certain temperature. Figure 3 shows how the temperature of the vegetable oil changed after the deep fat fryer was switched on. Determine the resistance of the electrical component when the heating element automatically switched off. Use figure 2 and figure 3. So this question came up a few years ago and it confused quite a lot of people because people started reading off this graph and saying the temperature was the resistance. When it isn't, it clearly says it's the temperature. Okay, what's the question asking for? It's asking for resistance. Well, this has given us time and temperature. The other graph has given us resistance and temperature. So if I want to know resistance, I need to know a value for temperature. To work out a value for temperature, I need to use this graph. So first thing I'm going to do is I'm going to work out what the temperature was when it switched off. So let's find out where, or what temperature it was at, where it was switched off. We can see it switched off, it stopped increasing in temperature here. What temperature is this? So I'm going to draw off the graph. If a question says that use figure 2 and figure 3, it is probably a good bet that you want to see evidence you have used figure 2 and figure 3. So I'm going to draw on the graph, and I'm going to look at what number this is given. Now, on the graph, how many divisions are there? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 divisions between 150 and 200. 50 divided by 10 is 5. So each of these small squares is going to be 5. Okay, so the temperature is going to be 160. So T equals 160 degrees Celsius. Okay, so far so good. That'll get us 1 mark. Now we know the temperature, so now we need to know the resistance. Let's flip over. Let's find where 160 is on this. So here's 150, here's 200. So how many divisions are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 divisions, 50 divided by 10, 5 again. So each of these small squares is worth 5. So 160 is going to be here. So I'm just going to draw a line up to here. And then I'm going to draw a line across. Very carefully, use a ruler. It does say on the front of the paper you will need a ruler. What is that going to give us? Okay, reading off the graph again. So this time it's between 200 and 400. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 200 divided by 10 is 20. So each of these squares is worth 20. So that's going to be 220, 40, 200, and that's between 240 and 260. So that's going to be 250. Okay. So that is going to be R equals 250 degrees Celsius. It is worth noting, 250 degrees Celsius, 250 ohms. Getting mixed up in my units. It is worth noting for graph questions there is going to be an acceptable range. Okay, and on the mark scheme it does say you will be allowed to use an answer in the range of 240 to 260. Okay. Moving on to the last bit, part G. Some chips were put in the deep fryer. In the deep fryer, water in the chips underwent a physical change and became steam. Why is this a physical change? Tick one box. Never leave multiple choice questions blank. Always pick something, even if you have no idea. Okay, let's go through them. All water can change to steam. Well, that is technically true, but that doesn't explain why it's a physical change. No chemicals are involved when water changes to steam. Well, again, technically true, but that doesn't explain why it's a physical change. The change from water to steam can be detected visually. Again, true, but that doesn't tell us about a physical change. And the last one, the water will recover its original properties the steam is cooled. It is this one. Okay, so the reason for this one, we need to remember the definition of a physical change is it can be easily reversed. So a chemical reaction, you can't easily reverse it. You have to introduce new chemicals into the reaction. But a physical change, if I boil some water, it is very easy to cool it down again and condense it. So that wraps up this question on specific heat capacity. So we've looked at, I've lost part of the sheet. We've looked at the required practical. So we've looked at how we conduct this required practical. We've looked at some questions on power and how to use that equation. We've looked at risks. We've looked at our graphs. We've looked at our electrical components, how to use the graphs, and also a bit on physical changes. Okay, if you have any questions, then please put them in the comments.